Hello everyone, I'm Siddharthan. This is the 19th project video in our machine learning project series, and in today's video we are going to discuss how we can build a breast cancer classification system using machine learning in Python. This is one of the standard use cases that we have in machine learning that is related to healthcare field. So first of all, let's try to understand more about this problem statement. Then we can discuss what is the workflow which we are going to follow for this particular use case, and then we can move on to the hands-on part where we will try to build this classification system in Python. Okay, so let's get started. So first of all, we need to understand the different types of tumor before going into this. So basically there are two types of tumors. One is benign tumors and the another one is malignant tumors. So tumor is nothing but we know that a human body is made of cells and tissues and organs and all those kind of things, and all the cells in our body divides and grows, right? And sometimes what happens is some of the cells in our body may divides repeatedly, without some control. So in that case it forms an abnormal mass, an abnormal tissue, and those abnormal mass is called as a tumor. So these tumors can be called as benign if those tumors doesn't move to the other parts of the body, whereas malignant tumors are those which have the capability to move to the other parts of the body. So all those malignant tumors are called as cancerous tumors, whereas the benign tumors are not that much harmful. So they are called as non-cancerous tumors. So the important feature of these malignant tumors is that they have the property of metastasis. So you can see this particular word here. So metastasis basically means when a tumor can travel from one part of the body and then it can move on to the other part. So say in this case we are discussing about a breast cancer, right? So what happens if malignant tumors is not treated is that, so we call those as cancerous tumors, and it has the capability to move on to the other parts like bones, brains, kidneys, and other kind of organs. So we need to determine whether that particular tumor is benign or malignant. So if it is a benign tumor, there is nothing to worry about, but if it is a malignant case, then the patient should be given immediate treatment. So that particular tumor has to be removed and they will be subjected to treatments like chemotherapy and radiation and so on. So in this use case, we are going to work on a data set which contains the details about this benign tumors and malignant tumors, and we are going to classify these tumors are benign or malignant. Okay, so this is the problem statement that we have, and let's discuss about the data set that we have now. So this particular data is derived from a test called as fine needle aspiration. So this is an example of a biopsy test where if a person is suspected to have some tumor, they will try to get some mass from that particular tumor and they will try to do some test on that particular tumor. So this is called as fine needle aspiration, and I have mentioned this particular procedure in this statement. So you can pause the video and go through this particular statement. You can also do some research on this. Okay, so this is one of the conclusive evidence that pathologists take. So a pathologist is a person who will basically conduct some test, blood reports, and all this kind of things, and they will try to find the diagnosis for a particular patient. Okay, so the data that we have is derived from this particular test called as fine needle aspiration, and this is the standard procedure in order to find whether a particular tumor is benign or malignant. Okay, and the data set that we have looks something like this. So we have the diagnosis here. 0 represents a person with a malignant tumor and 1 represents that that particular tumor is benign, so there is nothing to worry about. So these are the two kinds of things that we have, and we are basically going to classify these tumors as benign or malignant. And we have measurements like radius, texture, perimeter, area, smoothness, etc. So these are nothing but the properties of the cells. So as we have told, you can just read this particular definition. So fine needle aspiration is a type of biopsy procedure. So biopsy procedure means they use a needle to get some particular mass. So we call this as an invasive procedure, whereas there are procedures like ultrasound and the other kinds of scans. So a patient is not given any invasive treatment, whereas this is an invasive procedure which is called as a biopsy, where a needle is used in order to get that particular mass for testing. Okay, so a thin needle is inserted into an area of abnormally appearing tissue or body fluid. As with other types of biopsies, the sample collected during fine needle aspiration can help make a diagnosis or rule out conditions such as cancer. So this is all about a fine needle aspiration, and all these are the properties of the cells that are being tested. Okay, so once they have all this data, they will try to figure out whether that particular tumor can be benign or malignant. So this is the data set that we have, and we can use our machine learning models in order to find some relationship between the data so that we can classify these tumors. So this is all about the data set that we have, and now let's try to discuss about the workflow which we are going to follow. So the first step is data collection. So we will try to figure out the data which we are going to work on. And once we have this data set, once the data collection process is completed, we will process this data. So we cannot feed this raw data to our machine learning model. So there are some data pre-processing steps which we will cover here. And once you process the data, and then we need to split our data into training data and testing data. So the purpose of this is we will train our machine learning model using the training data, and then we will evaluate our model using the test data. So this is the purpose of splitting the data into training data and test data. And once we do that, we will train our machine learning model. So in this case, we are going to use a logistic regression model, because logistic regression is one of the best model when it comes to binary classification. So in this also we have a binary classification, right? Binary classification in the sense we are going to classify the data points into two types. Here the two types of are benign and malignant, or in other words it is nothing but 0 or 1, right? So here we are going to use a logistic regression model. So once you train your logistic regression model with this particular training data set, you will have trained logistic regression model, and we will also do some evaluation on this model using the test data. So once all those things are completed, we can have a new data, and once you give this new data, the model can tell you whether that particular tumor is benign or malignant. So this is what we are going to do in this particular use case. So I hope everyone is clear up to this point, and now we can move on to the hands-on part where we will try to build this system in Python. Okay, so let's get started. So I'll go to my Google Collaboratory. So here I'll just connect my Google Collaboratory system, and the first step is in order to import the dependencies. So first let's try to import the libraries and the functions that we need. So I'll just make a text here as importing the dependencies. So first of all, I'll import the basic libraries like NumPy. So I'll import NumPy as NP, and pandas as PD, and we are going to get this particular data set from sklearn. So sklearn actually has this data. So as I've told you, this is one of the standard use cases that a person learns while he or she is trying to learn machine learning. So we can get this data set basically from sklearn. So I'll import sklearn dot datasets. Okay, so you can also get this dataset from Kaggle. So if you import the dataset from sklearn, it will be in the form of NumPy arrays. Whereas if you want a CSV file, you can just go to Google and search as breast cancer dataset Kaggle. So you can see this particular Kaggle site here. So breast cancer Wisconsin diagnostic dataset. So this is the same datasets that we have in sklearn. So you can open this particular site. So there you can see here. So this is also available in UCI machine learning repository as well. So here you can see about the details about this particular data set. So when it was derived and other kind of things, and you can see all those information here. So all the input features that we have. So totally we have 31 columns here. So you can see here. So 10 of 32 columns. So if you want to download the CSV file, so go to the site and you can see this download option here. So data.csv. So this is the CSV file. You can download this CSV file from here, or you can use the dataset that we have in this sklearn. Okay, so as you can see here, we have two labels as B and M. So this is our labels where B represents benign and M represents malignant. Okay, and we have about 32 columns. So you can just go to this option and mention all. So if you do that, you can see all the columns that are present in this particular dataset. Okay, so you can just slide this and see all the data sets that all the columns that you have. So these are the main columns. So the radius, texture, perimeter, area, and all that. So basically, first of all, there will be a mean value, and then there will be standard error value and worst value for all these features. So first of all, like say for example, we have the radius, texture, perimeter, like all those columns, and then we have the standard error of radius, standard error of textures, and all those things. So again, you will have 10 different columns, and then you have this worst or largest value of all these values. So those are the 30 columns. So it's basically this 10 columns, and then the standard error and the worst value of again these 10 columns. So that constitutes about the 30 columns that we have in this particular data set. Okay, so let's discuss more about this, but first of all, let's try to import these dependencies. So we will use the data set from sklearn, as I've told you, and again you can use the data set from here as also. You can download it from this particular option. So and now I'm going to import my train test split function from sklearn dot model selection import train test split. Okay, so this particular train test split function is used in order to split your data set into training data and testing data. And then we are going to import our logistic regression model. So from sklearn dot linear model import logistic regression. Okay, so we have also discussed how we can build this logistic regression from scratch in Python, so you can also refer to that particular video. So in this we are going to use the logistic regression model that is available in sklearn. Okay, so now the last thing that we are going to need is the evaluation metric. So from sklearn dot metrics, I'm going to import my accuracy score. Okay, so this accuracy score is used to evaluate our model. In other words, it is used to determine how many correct predictions our model is making. Okay, so first of all, we will try to train this model using the data set that we have. So once we train that, we can give new values in order to so that the model can predict whether that particular tumor is benign or malignant. So we will also be making a predictive system for this particular use case. So this is the first step, which is importing the dependencies. So I hope everyone knows about this libraries. In case you are not sure about this, NumPy library is one of the important libraries that we have in Python, and it is used to make NumPy arrays. Okay, so we generally import this in the short form as NP. Okay, and pandas is the library which is very helpful in order to create pandas data frame. So generally the data sets that you have will be in the form of a CSV file or NumPy arrays. So we will load this data into a data frame which are more of structured tables. So that is the importance of pandas, which is used to create data frames, which helps us to analyze the data, process the data in a more structured way. And we import the pandas library in the short form as PD. And then we have the sklearn.datasets, from where we are going to import this breast cancer data. And then we have this train test split function, which we are importing from sklearn.model selection, and we are importing this logistic regression from sklearn.linear model. And finally we have also this accuracy score, which is used to determine how many correct predictions our model is making and all that. So the next step is data collection and processing. So this is our next step. So I have to make a text. Just a second. Okay, so this is our next step. As I've told you, you can use this data.csv file as well. So basically they are the same data, only the format is different. So in case you are using this data.csv file, you will be using the function pandas.readcsv. So that particular function in pandas. So pd.readcsv will read the data from the CSV file and it loaded to a data frame. So in this case, we don't have a CSV file. So we are going to use the dataset from sklearn. So I'm going to load the dataset from this particular library. So I'll just make a comment here as loading the data from sklearn. So I'll name this as breast cancer data. Okay, so breast cancer dataset. So I'm going to import this from sklearn.dataset, so which we have imported here. So sklearn.datasets, and in this we need to use this load breast cancer. So these are the simple data sets that we have in this sklearn.dataset. So in this we are going to use this load underscore breast underscore cancer. So this is the name of the data set that we have, and you need to mention this parenthesis. Okay, so I'll run this. So this will load the data from this sklearn library to my variable called as breast cancer dataset. So you can also try to print this breast cancer data. So this will be in the form of a NumPy array. So NumPy n dimensional array. So we have the data, right? So this values represents all these column values. So we have this radius and textures, perimeter, and all that, right? So these are all those values, and then we have 0 and 1. So this basically represents the labels. So labels where 0 represents malignant case and 1 represents benign case, and then we have the names of the columns. So you can see here, so we have the radius, so mean smoothness, mean compactness, and just a second, you can see this target names here. Yeah, so feature names. So feature names are nothing but the column names that we have here. So these are the column names. So smoothness, mean, compactness, etc. So you have all those things in this array called as feature names. So mean, radius, mean, textures, and all that. So The first array is the data array, which contain all the values, and then we have the target array, which contains all the labels, and then feature names, which contains the name of the features. So we need to load all these things to a pandas data frame. So that is our next step. So I'm going to load this data. So I'll just make a comment here as loading the data to a pandas data frame. So it will be more convenient for us to analyze the data and process the data once we load it to a data frame. So I'll name this as data underscore frame. Okay, so let's call this data frame. So you can give any name. So you can give the name as df and anything like that. So I'll name this as data frame, and we are going to use the pandas library. So if you remember, we have imported the pandas in the short form as pd, right? So pd dot, so pandas has a function called as data frame. So note that the D and F should be in caps, and in that we need to mention some parameters. First is the data that we have, breast cancer dataset. So the name of the dataset that we have loaded. So we have loaded this data in this name, right? So cancer dataset. So we need to mention this. So breast cancer dataset dot data and columns. So columns is equal to, again you need to mention the name of the dataset dot feature names. So what I'm basically doing here is I'm going to load all this data. So you can see here the name of the data is breast cancer data set, and we have we have this in the form of a dictionary. So you can consider this data as your key, and so you can consider this data as key and all the values as the values that are associated to it. So we know that in a dictionary there are key value pairs, right? So you can think about this like that. So we have the key value as data, and all the values are stored here. So if you want to access all those values, you need to mention the key, which is nothing but the data, and all the target values are present in the key called as target. And if you come here, all the column names or all the feature names are mentioned in the key called as feature names. So we need to mention all this. So when I'm mentioning breast cancer dataset dot data, I'm basically representing this particular aspect, because this array, so this array is called as data, right? So you can see the word here, data. So that's why I have mentioned breast cancer dot data, and columns is equal to, so in this columns parameter we need to mention the names of the features that we have. So the names of the features are nothing but, so all these things, so they are represented using this array called as feature name. So you can see here, so if you drag this here, you can see this feature names here. It contains all the names of the features or all the names of the columns. And if you want to access the target or the labels, you have to use the word called as target. So you will basically represent this as breast cancer dataset dot target. So this is how you can load the dataset from this particular sklearn arrays, sklearn numpy arrays to a pandas data frame. Okay, so I mentioned the data, and in this columns parameter I'm mentioning the feature names. So I'll run this, and now let's see how this particular data frame looks like. So I'm going to print the first 5 rows of this data frame. So print the first 5 rows of the data frame, and for that you need to mention the data frame name. So we know that we have named this as the data underscore frame, right? So we need to mention that here. So data frame dot id, and we need to mention the parenthesis here. So if you run this, it will print the first 5 rows in this particular. So you can see here this particular data is not very structured, so hence we are loading it to a pandas data frame, which is more of a tabular view. Okay, so we have the mean, radius, mean, texture, and all that. So first 10 values contains the mean of all these values, radius, texture, perimeter, etc. And then we have the next 10 values are again the same, radius, texture, perimeter, etc., but they are for the standard error for all those 10. And then we have the worst values. So these are the features that we have. So totally we have about 30 columns here. And now what we are going to do is, this doesn't contain the label column. Okay, so this contains only this particular data, so we need to include this target column as well. Okay, so that's what we are going to do here. So for that, what I'm going to do is, so this step is adding the target column. So adding target column to the data frame that we have. Okay, so we can let's name this column as label. So we need to mention the data frame, which is data underscore frame, so the name of the data frame that we have created. and we have to use the square brackets here, and within this you need to name your column. So I'll name this particular column as label. So you can give any labels, like you can also name this as diagnosis and anything like that. So I'll name this as label. So in this particular label column, we are going to add all these values, zeros and ones. So we are basically adding one more column to this particular data frame. So this doesn't contain the target column, so we are going to add that. For that, we need to mention the data set, which is breast cancer dataset dot target, because this target is the array which contain all these values, so 0 and 1. So target. So you can run this, and now again you can try to print the first 5 rows of the data frame, or you can also try to print the last 5 rows of the data frame. So printing, so I'm going to print the last 5 rows of the data frame here. So for that, again you need to mention the data frame name dot tail. So if you use this yet function, you will print the first 5 rows of the data frame, and if you use the tail function, it will print the last 5 rows of the data frame. Okay, so you can see the last 5 rows of the data frame. So the only difference between this particular data frame and this is that now we have added our label column. So this is the label column which we took from this particular data set, which contains either 0 or 1, where 0 being malignant and 1 being benign. Okay, so this is the data set that we have, and now we can just analyze this data. So let's discuss how many data points are there, what is some statistical measures about the data, and all those things. So the next step will be the basic analysis and processing. So I'm going to print the number of rows and columns in the data set. Okay, so that is our next step. For that, you need to mention the data frame name dot shape. So here you shouldn't mention the parenthesis, because what you will get will be a tuple. So this is basically a tuple object. So in case of tuple object, you shouldn't mention the parenthesis here. So if you mention those parentheses, you will get some error. Okay, so tuple object is not callable, so you need to remove this parenthesis. Whereas in the previous case, while we are using the set function and tail function, we use this parenthesis. Okay, so when you run this data frame dot shape, it will give the shape of your data frame. So 569 comma 31. So what this basically means is there are totally 569 different rows and 31 different columns. Okay, so 30 columns are for the input feature, and the last column is for our label. Okay, so 569 means we have the data for 569 different people. Okay, and this is what is this is how you can find the shape of the data frame that you have, and you can also get some information about the data. So getting some information about the data. So for that, you can use the function called as data.info. So dataframe.info. So it will give us some basic information about the data set. So it tells us what are all the different columns that we have, and whether it contains null values or not. So null values are nothing but missing values. So often in real world data set, what happens is a lot of the values will be missing. So in case the values are missing, what we will do is we will work on some techniques like imputation, where we will try to replace all those missing values with some mean values and median values and other kind of things. So we have already discussed about this imputation in our video in the fourth module, so you can also refer that. So the fourth module is called as data collection and processing in our machine learning course. In that, I have explained you how you can handle the missing values. So in this case, we don't have any missing values. So totally we have about 569 rows, right? So in each column we have 569 non-null values. Non-null values means these values are not missing. Okay, so null values means missing values, and non-null means those values that are present. So we don't have any missing values, and the data type for all those values is float. Okay, so it is a floating point. Floating point is nothing but a decimal value, and the last column is an integer value. It's only 0 or 1, so it will basically be an integer value. So this is how you can get the information about the data set, size of the data set, and so on. And there is also a specific way for us to find whether there are any missing values or not in our data set. We know that there are no missing values, but I'll show you a method which you can use in order to find whether there are any missing values. So this is checking for missing values. So these are all the standard things that we do in every machine learning use cases. So you can just take note of this. So I'm mentioning my data frame name dot is null dot sum. Okay, So this will tell you whether there are any missing values in each of the columns. So all the column names will be mentioned, and it will tell you how many missing values are there in each column. So 0 basically means there are no missing values in any column. So that's why we have here. And in most of the cases, we will basically have some missing values and we need to deal with it. So in this case, we don't have that. So we can move on to the other aspects. So now we are going to, find some statistical measures about the data. So this step is statistical measures about the data set. So often in if you're working mainly on data analysis aspects, all these things are needed, but we don't need all those things. So we just need some basic information about this data, and this is how you can get it. So you can find the values such as what is the mean value, standard deviation, and all those things. So mention data frame dot describe. So describe parenthesis. So this describe function is used in order to give us some important statistical measures about the data. So we have all the columns here, right? So all the columns are here, and we have the count. So count basically tells you how many values are there in each column, and then we have the mean value. So this particular thing gives the mean value for all the values in this mean radius, and we also have the standard deviation value, and what is the minimum value in this column, and what is the 25th percentile. So these are not percentage values, these are percentiles. So there is a difference between them. So 25 percentile means 25 percentage of the values are less than 11.7. 50th percentile means 50 percentage of the data are less than 13.37, and so on. And then we have what is the maximum value here, and so on. So we have all these statistical measures for all the columns in our data set. So now we can move on to the other aspect. So now we are going to see how many benign cases and malignant cases are there. So we are going to basically count how many 0 values and 1 values are there in our data frame. Okay, so this is checking the distribution of target variable. So target variable is nothing but our labels. So yeah, so mention the data frame label. So we have named this as label, right? So we have created a column called as label. Yeah, so this is the column that we have created here, and we have used all these target values, right? So we are going to call this particular column called as label. So you need to mention the name of this label. So data frame within this square brackets mention label dot value counts. So let's run this. So here, as you can see here, so totally we have 357 values as 1 and 212 values as 0. So we know that 1 represents malignant and 0 represents, 0 represents malignant and 1 represents benign. So you can also see here, so I'll come to this Kaggle data set. So just a second. So you can see here, so totally we have about, actually, I think it's mentioned here. Yeah. So totally we have 357 benign cases, right? So and 212 malignant cases. So you can just compare this with 1 and 0. So 1 represents 357, which is basically the benign cases, and 212 is malignant cases, which is represented as 0. Okay, so we have just basically labeled all the malignant cases as 0 and benign cases as 1, whereas in this particular CSV file it will be in the form of B and M. So if you use the dataset from this sklearn, it is actually labeled as 0 and 1. Okay, so it is better to have the label as this integer values rather than having character values as B and M. So that's why we are using this particular data set, and you can also get more information about this if you search for UCI machine learning repository. So that particular repository contains the original data set for this particular data set. So the one main thing that you need to understand here is 1 represents for benign data points, and 0 represents data for the malignant data points. So I'll just make a text here as 1 represents benign, and let's say that this 0 represents malignant. So malignant tumors are those which can spread to other parts of the body, which is more riskier than the benign, which is not that much riskier when compared to malignant cases. So now we are going to group this data set based on the label that we have. Okay, so I'll mention data frame dot group by and mention label here, label dot mean. So what I'm going to do here is, so we are going to take all these values for 0 and 1. So like what happens basically here is all the values for the zeros will be taken. So all the malignant cases will be taken and the mean value will be determined for all the columns, and then the same will be done for the benign case as well. So I'll run this, you will understand. So we have two labels here, right? So 0 and 1. So all the values in each column will be taken for malignant cases, which is represented by 0, and the mean value will be found for all the columns, and then the same is done for the benign column. So the important reason that we are doing here is, you can just look at the data that is present here, the value of the data present here. So we know that 0 is malignant, which is a more riskier state, and 1 is benign, which is nothing to fear in that particular case. So in the case of malignant, all the values are slightly larger than the values of the benign cases. So you can see the mean radius. So these are all, we know that values of the nucleus of the cells that are being studied. So we have the mean radius value, the mean of this entire value is around 17 for all the malignant cases, where it is slightly lesser for benign cases. Again, the texture value is high, whereas in this case it is low, and so on. So we can see a clear distinction between the malignant case and the benign case, and in the malignant case all the values are almost greater when compared to this benign case. So this is one of the important difference that we can see in this data set, and this is going to be very helpful for our model in order to differentiate the data, in order to differentiate and see whether a person is having benign tumor or a malignant tumor. So this is very, very important. Okay, so this is how we can manually look at the difference between the two classes of the data that we have. So the next step will be splitting that input features and the target. So all these are called as the input features. So all the 30 columns from this mean radius all the way to this worst fractal dimension. So all these are called as the input feature, and the last column label. So this is called as the target column. So we are going to separate this data. Okay, so the reason is that we will try to feed this data. So all these data, all these input features are called as X, and all the label values are called as Y. So this is basically like fitting a curve to x-axis and y-axis. So we will take all the input features as Rx, and the label value as y. So we need to separate this x and y. So all the 30 columns will be considered as x, and this label column will be considered as y. So this is one of the important things that we need to do, because while fitting the data to our machine learning model, we will fit it with this x and y. So this part will be separating the features and target. Features are nothing but all the columns except the target column. Features and target. So once we train the model, so once you give the feature values, it can predict the target value, whether it is either 0 or 1. Okay, so I'll name two variables here, x and y. So x will be my input feature. So what I'm going to do is, I'm going to take my data frame and I'm going to drop only one column. So I'm going to drop my label column. So column is equal to label, and axis is equal to 1. Okay, so what we are basically doing here is, we are taking our data frame and we are dropping the label column alone, because we need all the features separately, right? So we will be dropping this label column alone, and we will be storing this label column in y. So it is a very simple procedure. So I'm dropping the column and I'm mentioning this axis as 1. So whenever you are dropping a column, you need to mention the axis value as 1, and whenever you are dropping a row from a data frame, you will mention the axis value as 0. So here we know that label is a column, right? So we are mentioning the axis value as 1, and this y will be the label column. So data frame, and in the square brackets mention label. So we are storing all the values except for label in this x, and all the labels values are stored in this y. So you can try to print this x and y. So this contain all the input features. So we totally have 569 rows and 30 columns, and as you can see here, there is no label column here anymore. So x doesn't contain the label column, and you can try to print this y. So y contain all the labels, either 0 or 1. So again, it contains 569 values, the corresponding labels for each column. So you can see the first row. So the first row is numbered as 0. So the label for this first row is 0, the corresponding label here, and for the label for this second row, which is represented by this numbering 1, so the label for this particular column is this 0, again 0. So we have the labels in this particular y variable. And now what we are going to do is we are going to split our data into training data and testing data. As I've told you, we use the training data in order to train our machine learning model, and we will use the test data to evaluate our model. So we need to separate this data set as training data and testing data. So splitting the data into training data and testing data. So this is the next step. So this is also one of the important steps that you need to remember. So I'm going to create 4 arrays here. So they are xtrain, xtest, and ytrain, and ytest. So these are the 4 arrays that we have, numpy arrays. And I'm going to use the train test split function. Okay, so train test split. So I'll just complete this line of code and I'll explain you what I'm doing here. So test size, we can give the test size as 0.2, and you can give some random state. Random state is equal to 2. Okay, so here first we are creating 4 arrays: xtrain, xtest, ytrain, and ytest. So what we are doing here is, so this x value, this x array will be split into 2 parts. One is training data and the testing data. The training data is called as xtrain, and the testing data is called as xtest. And the corresponding labels for all the values in this xtrain is stored in this ytrain, and all the corresponding labels for this xtest is stored in this ytest. So you can just consider these two things: xtrain and ytrain. Okay, so the labels for this xtrain is present in this ytrain, and the xtest labels is present in this ytest. So we are basically splitting this x and y into two groups of data. One is training and the other one is testing data. Okay, so these are the 4 arrays that we are creating, and for this we are using the train test split function. So where does this train test split function comes from? So we have imported it. So in the first cell, we have imported a train test split function from sklearn.model selection. Okay, so this function will help us in order to split our data into training and testing data. And we have some parameters here. So just a second. Yeah, so we need to split this x and y. So we need to mention them in this particular parenthesis. So x and y, because I'm going to split this x and y alone. And we have this test size as 0.2. So 0.2 basically means, like, out of this entire data set, out of this 569 rows, I want 80% of my data to be training data and 20% of the data to be test data. So that's why we have mentioned 0.2. So 0.2 is nothing but 20%. So 20% of data will be your test data, and the remaining data, which is 80%, will be your training data. And then finally we have a random state. So this is not actually very important. So the what this random state do is, so each time you run this train test split function, your data will be splitted in a different way. Okay, so it won't be splitted in the same way. But if you use this random state value as some number, it will be splitted in the same way. Let's say that you are practicing this code, and you are splitting this data set again, and if you mention this random state is equal to 3, your data split will be splitted in a different way. But if you mention the same number that I'm using now, your data and my data will be splitted in the same way. Okay, so this is just for a way of splitting the data. So this is just basically to reproduce the code, reproduce how it has splitted the data before, and so on. So that is the importance of random state. So you can run this, and now you can try to print the shape of x dot shape. Again, you shouldn't mention parenthesis for this shape, as it is a tuple data type. So it should be just x dot shape. So you shouldn't mention the parenthesis like this. So x dot shape, and then we have to mention xtrain dot shape. So now we are just checking how many data points are there in our training data and test data. Shape and x test dot shape. So x is my original data set, right? So x is the original data set that we have without the label column, and x train is my training data, x test is my testing data. So I'll run this. So as you can see here, so the original data set contains about 569 data points, and out of those, 80% of the data, which is 455, comes into this x train, and 20% of the data, which is 114 values, comes to this x test. Okay, so this is how we can split our data into training data and testing data. And we are almost in the last part of this particular use case, which is to train our logistic regression model. So this step is called as model training. model training, and here we are going to use a logistic regression. As I've told you earlier, logistic regression is very useful for binary classification problem where you just have two classes. In this, the two classes that we have are benign and malignant. So logistic regression, and we have already imported this logistic regression from sklearn.linear model. Okay, so from sklearn.linear model we have imported this logistic regression model. So we are going to use this. As I've told you, we have already tried to build this logistic regression model from scratch in Python in our channel, so you can also refer that video as well if you want a detailed explanation on what is meant by this logistic regression or when to use that and all those kind of details. So this particular video we are just going to see the implementation of it. So I'm creating a variable called as model, and within this I'm going to load an instance of this logistic regression model. So mention logistic regression and parenthesis. So I'm loading an instance of this logistic regression to this variable called as model. So run this, and now we are going to fit our data set, fit this X train and Y train to our logistic regression model. So this will be training the logistic regression model using training data. So training data are nothing but X train and Y train. So I'm going to use this model. So this model is now is nothing but this logistic regression that we have loaded. So model dot fit. Okay, so model dot fit X train and Y train. So this is just like X coordinate and Y coordinate data. So we are going to fit these two data to our logistic regression model, and it will, what happens here is it will try to figure out the relationship between this X train and Y train. So how this all the values, all the input feature values are related. So you can see all the input feature values, right? So you can see the 30 columns here. So from mean radius all the way up to worst fractional diameter, which is our X, and this label is our Y, right? So it will basically try to find the relationship between all those X values and the Y value. So now it knows, like, how the data looks like if the label is 0, and it also knows how the data looks like if the label is 1. So that's what basically happens when you try to fit a logistic regression model with some data set. So it tries to learn it repeatedly. It will try to go through the data repeatedly, and it will try to find a best fit for this particular data set. So let's run this, and this will train our logistic regression model, and now we can evaluate our model. We can see how well our model is performing and all that. So this part is about model evaluation. Okay, so model evaluation, and for classification problem we basically use a metric called as accuracy score. Okay, and let's see how we can use this. And we have already imported this accuracy score function from sklearn.metrics. So accuracy score, and this will be, first let's try to find the accuracy on training data. So we have trained our model with this X train and Y train, right? So we will try to give this X train alone now, and we will ask our model to predict the label values, and then we will compare the predicted values with this true value, which is Y train. So first we will train evaluate our model with the training data, and then we will evaluate it with the test data that we have, which is X test. Okay, so this is accuracy on training data. So this is the first step, and I'm going to create an array called as extrain prediction. So I'm going to predict all the values, and I'm going to store all the label values in this extrain predictions. So I'm going to use this model.predict. So again, model.predict is a function which is used to predict the label value. So the two functions that we are using here is fit and predict. Okay, so the fit function is used to fit the data set to our model, and once your model is trained, so when you run this fit function, your logistic regression model will be trained with the data set, and after that you can use this predict function in order to predict the label given the X values. Okay, so that is what this particular thing is all about, and I'm going to use my X train value. So what happens basically here is, so I'm going to give my extrain values, and I'm going to predict whether the label is going to be 0 or 1 using my model. Okay, so all those values predicted by my model will be stored in this extrain prediction. So this is the predicted values. So this predicted values will be compared with the true values. So the true label values is nothing but Y train. Okay, so the true values that are present in our data set is called as Y train, and I'm going to compare this Y train and the X train predictions. Okay, so it's let's see how we can do that. So if you use this accuracy score, you can get that particular value. Let's name this as training data accuracy, and here we can use the accuracy score function, and within this we need to mention the true value, which is y train and this x train prediction. Okay, so here your y train is the true value and the x train prediction is your predicted value, so the value which is predicted by your model. So we are comparing these two values using the accuracy score function, and that particular value will be stored in this training data accuracy variable. So let's run this. So it will give this value to this training data accuracy now, and we can now try to print this accuracy value. So use a print function, print, and I'll just mention some text here as accuracy on training data is equal to, so you can just copy and paste this particular value here, training data accuracy. So it will try to give you the what is the accuracy. So the accuracy is about 0.949, so it is around 0.95, right? So 0.95 means 95 percentage. So in other words, out of 100 data points or out of 100 cases, your model can predict correctly for 95 cases, and this particular accuracy is actually very high, right? So like out of 100 times you can get correct prediction for 95 values, which is actually high. So this is the accuracy value on our training data, but as I've mentioned earlier, the accuracy value on test data is very important, because test data is mainly used for evaluating the model. So that is the reason why we try to find the accuracy score for this training data. I'll tell you that in the next step, but now let's try to do the same thing. So let's try to find the accuracy score, but in terms of this the test data, which is x test and y test. So I'll just copy these cells. So I'll just copy this. We just need to do some small changes. So I'm going to change this to accuracy on test data, and instead of x train we should use x test. Okay, so x test is nothing but as you can remember, we have splitted the data into training and test data, and the test data is called as x test. So we will be giving only this x test value, and we will be predicting the x test labels. Okay, and again this should be y test, and this should be x test prediction. Okay, so and this is test data prediction. So we are just basically doing the same thing, but we are changing the data set that we have. So we are evaluating our model for test data. So I'll run this, and again we can print this accuracy score, accuracy on test data. So test data accuracy. Okay, so now we can print this and we can check the accuracy score now. So in this case, the accuracy score is about 93 percentage. So for the accuracy score on training data is around 95, and in the case of test data it is 93 percentage, which is also very high. So the reason we are trying to find the accuracy score for both training data and testing data is that sometimes our model tends to overfit in the sense it will try to learn more from the training data. So in that case, what happens here is, so your accuracy on training data will be it will be like very high, whereas the accuracy on your test data will be very low. So if you have an accuracy score of about 95 percentage on a training data, the test data accuracy can be 50 percentage or 60 percentage. So that means your model has overfitted. So what overfitted models will do is, it can only make correct predictions for the training data alone, but it cannot make correct predictions for the test data. So that is the reason we will always try to check the accuracy on both training data and the test data as well. But the accuracy on test data is what is actually very important for us. So this is how we evaluate our model, and we are in the last step of this particular use case, which is to build a predictive system. So now we know that our model is trained, right? So if you give a x value, it should predict whether the label is either 0 or 1. In other words, whether the tumor is benign or malignant. So that's what we are going to do now. So we have already seen this in multiple projects. So it is actually the same thing. So building a predictive system. So I'm going to create a list here as input data. List or tuple, you can just create anything. So input data. Okay. So in this, I'll copy and paste some values. So you can see this CSV file, right? I have downloaded this particular file. So you can see that particular file here. So, and I'm going to open this with my notepad. So this contains the ID number. So we don't need this ID. Okay. So this is the data set that I downloaded from Kaggle. So we have the ID and the diagnosis. So diagnosis tells you whether, it's benign or malignant, and M represents malignant, and B represents benign. Okay, so and then we have all the other values. So I'm going to copy some random values here. So I'll just copy this particular value. So remember what is the label in this value. Okay, so in this case the label is M. Okay, so M basically means malignant, and the label for M is 0, right? So once we feed this data to our model, it should tell that the label is 0. So let's see how it is predicting. So that is what we are going to do here. So I'll paste that particular value in this input data. Okay, so now I'm going to convert this tuple. So this is basically a tuple. So when we put the values in this parenthesis, it's called as a tuple. So it is a different data type, and I'm going to convert this to a NumPy array because we need to do some processing before we can feed it to our logistic regression model. So this step is to change the input data to a NumPy array. Okay. So we know that we have imported the NumPy as NP, right? So this will be to convert it to a NumPy array. So I'll name this as input data as NumPy array. So you can just give short names. So I don't want to give short names because it will be a bit confusing when you just look at the code. So I'm just putting it in a longer format, but you can just name this in a short form as well. So input data as NumPy array, and for this we are going to use the function from NumPy as np.asArray. Okay, so np.asArray, and within this you need to mention this input data. So what happens here is this tuple will be converted to a NumPy array now. So this is the second step, and then we need to reshape this array. So this reshape the NumPy array as we are predicting for one data point. Okay, so the reason we are doing here is, so in previous cases we have trained our model with about 455 data points and so on, right? And then we tested with a lot of data, but the model doesn't know how many values we are predicting. So we need to reshape this array so that the model knows that we want to predict the label for only one value. So that's why we will reshape this array, and let's name this as input data reshaped. So we cannot do this in the case of tuple and list. So that's why we are using a NumPy array. Okay, so that's the reason we have converted it. So input data reshape is equal to, so mention the name of the array, and we have the function called as reshape 1 comma minus 1. So this will reshape this array in this particular shape, and then now the model knows that we want to predict the label for only one value. And then now we are going to make the prediction. So prediction is equal to model.predict. So as I have told you earlier, this predict function is we have this predict function in this logistic regression, so which we have already used in order to predict the labels for xtrain and xtest. So we are going to use the same function. So when you give some value for this particular predict function, it will give you the label value. So we are going to predict the label for this particular input data reshape, right? So I'm just going to paste this, and you can try to print this prediction. So print prediction. Okay, so I am predicting the value, and I'm storing that particular prediction value in this variable called as prediction, and you can try to print this. So you can run this. So now the model should give the label value as 0. So we know that malignant are represented by the label as 0, right? So I'll go to this particular, yeah, so we have represented here. So 0 is represented as malignant. So we know that this particular data point that we copied is for the malignant case. So so it is M. So it should give the label value as 0 because 0 represents malignant. So let's run this and see whether the model is predicting the values correctly. Yeah, so you can see here, so we have the value as 0. So we know that 0 means malignant, right? So you can also try the same for benign cases as well. So let's just add one more thing. So I'm going to add if condition here. If my prediction value is 0, okay? So if my prediction value is equal to 0, in that case I want to print that the breast cancer is malignant. Is malignant, and else. So if else basically means if the value is 1, then we can print that It is benign. So this is what we are going to do. So if the label value is 0, it will tell it is malignant. If the label value is 1, it will tell it is benign. Okay, so you can run this. So the prediction will be basically in the form of a list. So we know that the values enclosed in square brackets is in the form of a list. So all the values you get will be in the form of a list, and I am accessing the first value. So when so this particular list is nothing but your prediction variable. So this is the list that we are getting, and prediction square bracket 0. So what this means is the first value in this prediction list. So if that particular first value, so we know that there is only one value, so that's why we are mentioning this. So if that value is 0, then we can call this as malignant. If it's not the case, in the sense, if the value is 1, I want this to be printed as benign. Okay, so you can also print, copy the data for some benign case. So I'll copy this. So here you can see the label as B, and you can copy this value, and I'll paste it here. So in this input data, so you can change the value here, and once you paste this particular data here, now it should tell us that it is a benign case. Okay, so let's see whether it is predicting correctly or not. So now you can see here, so the label value is 1 and the breast cancer is benign. So this is how you can build a predictive system, where if you give all those X values, all the features, it will try to print the label value. So this error is not actually important. So what it tells is X does not have valid feature names. So the reason is that, so if you see here, so in this X we have this mean radius, mean texture, and all that. So we have this feature names here, right? So we trained our model along with the feature names, but when we are giving the input data, we are not mentioning that particular feature name. So that's what it is mentioning here, but it is not a problem. So we are just getting the predictions correctly. So that's what is important, and this is how you can build a predictive system. Okay, so I hope everyone is clear up to this point. I'll just give you a quick recap of what we have done all along, so that you can just understand all the things clearly. So the first important step is importing the dependencies, and this is what we do in any Python programming. So we have imported all the libraries that we need. So the important libraries are NumPy, Pandas, and sklearn, and we have imported this train test split function for splitting our data into training data and testing data, and then we are using this logistic regression model, and accuracy score is used to evaluate our model to find what is the correct predictions percentage. And we need this NumPy for creating NumPy arrays and Pandas for creating data frames. And here we have loaded the data set from the sklearn library, and once we do that, we are loading that particular data to a Pandas data frame, and we are naming this as data underscore frame. Okay, and for this we are using the function from Pandas, which is called as data frame, and in that we are calling the data from this particular sklearn dataset, and the feature names, which is for our column names. So you can print the first 5 rows of the data frame using the set function, and after that we are adding the label column. So label is nothing but the target, whether it is either 0 or 1, where 0 being malignant and 1 being benign, and we are adding that particular column, and we are trying to print the last 5 columns in our data frame. Now you can see that there is a label column added here, and after that we are trying to see how many rows and columns are there using the shape function, and then you can get the information about the dataset using this info function, and then we are trying to see whether there are any missing values in the data frame. And the next step is to get some statistical measures about the data, which we can do by using the describe function. And the next step is some basic data analysis part. So how many 1 values are there and how many 0 values are there. So we found that about 357 values are benign cases, which is represented by 1, and 212 malignant cases represented by 0, and we can group this data based on the labels. And we have seen that so this is one of the most important insight that we get. So all the values are slightly higher for malignant cases compared to the benign cases. So you can see the clear difference between these two values in the 2 rows. Okay, and then we have splitted all the X value and Y values, X being all the features and Y being our target. And after that, we have splitted this X and Y into our training data and test data. And then finally, we have trained a logistic regression model from sklearn. So we have fitted the X train and Y train. So once the model training is done, we are trying to find the accuracy value for training data as well as the test data. And the final step is about building a predictive system which tells us whether the cancer is benign or malignant. Okay, so I hope everyone is clear up to this point. Soon in my channel, I'll try to upload videos on model deployment. So I hope that is one of the most requested videos in my channel, so I'll surely work on that soon. So I think everyone is clear for this particular project, so you can just try this on your own and see how this particular thing works. Okay, so that's it from my side, and I'll see you in the next upload. Thanks for watching.